Hello friends, the topic for today is 8254 Programmable Interval Timer Architecture. The 8254 is a programmable interval timer counter specially designed for use in real-time applications for timing and counting functions such as binary counting, generation of accurate time delays, generation of square wave, rate generation, hardware, software trigger, strobe signal, etc. In today's video, you will learn the features of 8254 Programmable Interval Timer with its block diagram and pin diagram. Let us start. Welcome to our channel Engineering and Technology for You. If you have not subscribed to our channel, kindly subscribe to our channel and press the bell icon to get notifications about the future videos. Let us start with the topic 8254 Programmable Interval Timer Architecture. Introduction. The Intel 8254 is a counter timer device designed to solve common timing control problems in microcomputer system design. It provides 3 independent 16-bit counters, each capable of handling clock inputs up to 10 MHz. All modes are software programmable. 8254 is a superset of 8253. 8253 it works up to 2 MHz. The 8254 uses HMOS technology and comes in a 24-pin plastic or SerDip package. Let us see the features. Compatible with all Intel and most other microprocessors. So it can be used with other microprocessors as well. Handles input from DC to 10 MHz. 8 MHz it is 8254 IC and 10 MHz it is 82542. Then status readback command. This command is there in this IC. Then 6 programmable counter modes. 3 independent 16-bit counters. Then binary or BCD counting. There are 2 formats for counting, binary or BCD. And we have 3 independent 16-bit counters and each of them can work in this 6 programmable modes. Then it has a single plus 5 volt supply, standard temperature range. So these are some of the features. Let us now switch on to the functional description. The 8254 is a programmable interval timer counter designed for use with Intel microcomputer systems. It is general purpose multi-timing element that can be treated as an array of I/O ports in the system software. 8254 solves one of the most common problems in any microcomputer system, the generation of accurate time delays under software control. This is necessary for some of the industries in automation or the other industries. Instead of setting up timing loops in software, the programmer configures the 8254 to match his requirements and programs one of the counters for the desired delay. So for getting accurate delays it is used, and after the desired delay 8254 will interrupt the CPU. Software override is minimal and variable length delays can be easily accommodated. Then let us come to the general functions of counter timer. Some of the other counter timer functions common to microcomputers which can be implemented with the 8254 are real-time clock. So this is a commonly used real-time clock. Then event counter. So any event can be counted with the help of this IC. Then digital one shot. Then programmable rate generator. So rate generator is one of the function generally used for the baud rate generation. Then square wave generator. Then binary rate multiplier. Then complex waveform generator. So you can use it for the generation of complex waveform. Then complex motor controller. So as we can generate complex waveforms, we can control the complex motor. So these are some of the functions of the timer IC. Then block diagram. So here is the block diagram. It consists of 6 blocks: data bus buffer, a read write control logic, control word register, then counter 0, counter 1 and counter 2. So these are the 6 blocks, and there is an internal data bus. Now here we are going to see each of these blocks in details. Let us go for the data bus buffer. Now it is connected to the data bus D0 to D7. Then read write control logic, and the various signals we are going to see. First, data bus buffer. This is a tri-state or 3-state bidirectional 8-bit buffer used to interface the 8254 to the system bus. So the data bus D0 to D7, that will be connected to this. Then read write logic. The read write logic accepts input from the system bus and generates control signals for the other blocks of the 8254. A1, A0 select one of the 3 counters or the control word register to be read from or written into. A low on read input tells 8254 that CPU is reading one of the counters. So this is active low. So it will be read bar. Then a low on WR input tells 8254 that CPU is writing either a control word or an initial count. Then both RD and WR are qualified by CS. So that is nothing but the chip select. So read bar and WR bar are ignored unless the 8254 has been selected by holding CS low. So chip select, this signal should be low in order to select the 8254. Then this is the block diagram showing the data bus buffer and the read write logic function. So you can see here data bus buffer, it is connected to the data bus D0 to D7. Then read write logic, it has got read bar, write bar, both are active low. Then A0 and A1, these are the 2 address lines, and a chip select CS bar, again it is active low. Then let us go to the next, that is control word register. The control word register is selected by the read write logic when A1, A0 is equal to 1, 1, both are high. If CPU then does a write operation to 8254, the data is stored in the control word register and is interpreted as control word used to define the operation of the counters. So when we write the control word to 8254, and the bit pattern that will define the operation of the counters, different modes of the counters. Then the control word register can only be written to status information is available with the read back command. So here control word register will have to write only, but we can get the status information from the read back command. Then let us see the block diagram showing the control word register and the counter functions. So this is the control word register, and then we have the counter 0, counter 1 and counter 2 with this clock 0, gate 0, out 0. This is with clock 1, gate 1 and out 1, clock 2, gate 2, out 2, these signals. So these are for connecting the counters with the external world. Let us see the counters now. Counter 0, counter 1 and counter 2. These 3 functional blocks are identical in operation. The counters are fully independent. Each counter may operate in a different mode. The actual counter is labeled CE, that is counting element. It is a 16-bit presetable synchronous down counter. Then OLM and OLL are the two 8-bit latches. OL stands for output latch and M and L stands for most significant byte and least significant byte respectively. So since this is a 16-bit counter, we have two latches, OLM and OLL. Both are normally referred to as one unit and are just called the OL. That is output latch. Then let us go further. These latches normally follow the CE, that is the counter element. But if suitable counter latch command is sent to 8254, the latches latch the present count until read by the CPU and then return to the following the CE. So when the latch command is given, at that time it will latch the present count and then that count is read by the CPU. One latch at a time is enabled by the counter's control logic to drive the internal bus. This is how the 16-bit counter communicates over the 8-bit internal bus. Similarly, there are two 8-bit registers called CRM and CRL for count registers. Both are normally referred to as one unit called as the CR, that is count register. When a new count is returned to the counter, the count is stored in CR and later transferred to the counter element CE. The control logic allows one register at a time to be loaded from the internal bus because the internal bus is 8-bit. Then both bytes are transferred to the CE simultaneously. CRM and CRL are cleared when the counter is programmed. In this way, the counter has been programmed for 1 byte counts, either most significant byte or least significant byte only. The other byte will be 0 at that time. Note that C cannot be written into, whenever the count is written, it is written into this CR, counter registers. The control logic is also shown in the diagram. Here clock N, gate N and out N are connected to the outside world through the control logic. So for each of the counter it will be, say for counter 0 it will be clock 0, gate 0 and out 0 and so on for the other counters. So let us see the diagram. So this is the internal block diagram of the counter. So this we have the counter logic here. Then this clock N, gate N and out N, these signals are connected here, and then here we have the control word register, the status register and status latch, register and latch. Then here this is the counting element C, and then we have OLM and OLL, these two output latches, and CRM and CRL, the counter registers, and all are connected to the internal bus which is 8-bit. You can see this. So this is how the internal block diagram of the counter. Then let us go to the pin diagram. So this is a 24-pin IC dual inline package. So 12 pins on this side and 12 pins on this side. So it has the data bus here D0 to D7, then clock 0, out 0, gate 0, and then ground signal, then out 1, gate 1, clock 1, then gate 2, out 2, clock 2. So these are all the signals of the counter 0, counter 1 and counter 2. Then A0 and A1, these are the address lines. Then chip select bar, read bar, WR bar, write bar and VCC. These are the signals 24 pin IC. Then let us see the pin description. So we have the D0 to D7. This is nothing but the data, bidirectional tri-state data bus lines connected to the system data bus. Then clock 0, CLK 0, that is the clock 0, clock 0, clock input of counter 0, then output 0, output of the counter 0, then gate input of the counter 0 is gate 0. Then we have ground power supply connection, ground power plus 5 volt power supply connection. Then write control, this input is low during the CPU write operation. Then read control, this input is low during the CPU read operation. Then chip select, a low on this input enables 8254 to respond to read bar and write bar signals, and read bar and write bar are ignored otherwise. Then A0, A1 address used to select one of the three counters or the control word register. So 0 0 it will select counter 0, 0 1 it will select counter 1, then 1 0 counter 2, and 1 1 control word register. Then CLK2 is the clock 2, clock input of counter 2. Then out 2 is nothing but output of counter 2. Gate 2 is gate input of counter 2. Then clock 1 is clock input of counter 1. Gate 1 is gate input of counter 1, and out 1 is output of counter 1. So this is the pin description. So with this we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And if you want to get notifications, press the bell icon. And thanks for watching. Have a nice day.